let's take a look at this graph here. I hope from the previous classes you could see that over here, object starts from rest, he moves away from the origin. So basically, if he was right here, let's say this is the 60-meter mark, and well, let's make that the 60-meter mark. So this guy starts from here, he goes over there, that means he got over there at the 60-meter mark. He waits there, he's not going anywhere. See, time is ticking, but he's staying in the same place. So what means that he's at rest? You could look at his velocity. His speed is positive, or his velocity is positive because he's going that way. Then his velocity is 0 because he's at rest over here. And then he comes back to the 0 point. Okay? Again, I'm going to keep drawing it like this so you guys got to understand that motion is that way. Time is going that way. And so there's no part of his motion where all of this is what he looks like. All right? And he went there faster than he came back, because he went there in 2 seconds, but he came back in 3 seconds. All right? And to find the speed, it's pretty easy. You find the slope here. Be 60 is your rise, and 2 is your run. So he's going at 30 meters per second. Then he's at rest. And then he comes back to rest in 3 seconds. So then on the way back, he goes a distance of 60. Well, you might say the run is negative 60 because it's 0 minus 60. So negative 60 because it's a drop, not a rise, over the run, which is 3 seconds, 60 meters. And that gives me negative 20 meters per second. And again, that's my velocity there, negative 20. And here's my velocity here is 30 meters per second. So I'm going faster, coming back slower. Here I'm at 0 meters per second. And you know, there's no really such thing as going from 30 to 0 right away. You know, there's just no way this can be really sharp. It's always a little roundy. All right, but we'll show them in graphs sometimes to be sharp. It's always a little roundy. All right. So there's your thing that tells you, you know, where you went, You could figure out all kinds of stuff here. Now, if I were to ask you what's his speed here, you would say 20 meters per second. You wouldn't put the negative up there. That's only when I'm asking about velocity. Okay, remember, speed with the direction is velocity. And again, going left or going down is negative, going right and up is positive, and so that's how we describe which way he's going. And sometimes we're going, oh, this is X and Y, this is not the same kind of graph anymore. This is the position. So moving, you might be moving that way, so you're moving a little bit in the X and a little bit in the Y, and we're going to work with those two. That's why I had you guys do all that trick stuff. Okay, but now, back here, well, the honors kids had to do the trig stuff, not the other ones, the regular physics kids. Okay, so we have this 30, negative 20. Again, here we're talking about velocity, and here we talk about speed. Speed here is 30, speed there is 20. And obviously, if I asked you, hey, how fast were you driving? And you go, I'm going negative 40 miles per hour. I'd be like, what? Because you're always asking about speed. You're generally not talking about velocity. All right, so now back to looking at some other terms. We have position that we write as x, and then we have a change in position which we write as delta x. And delta is Greek letter, delta. So it's a fancy way of saying change in. That's all that is. Okay? So now you can sound all cool and sciencey by saying, oh, it's delta x. But delta just means a change in position. And that just means change in anything is always final minus initial. If you were 60 pounds and now you're 55 pounds, then your change in weight was negative 5 pounds. Final minus initial, 55 minus 60. And if you put on weight and you went from 60 pounds to, say, 65 pounds, then your delta W would be positive 5 pounds. And delta is just a change. I'm just interested in the change. I'm not interested in how much you weighed before. It's the same thing with position. If I write this, I'm interested in exactly where you are. And when I write this, I mean I want to know what was your change in position. And so change in position is simply, your delta x simply means final minus initial, because that's a change in anything. It's just final minus initial. And I'm putting these little subscripts here just to show you final minus initial. So, I mean, you know, x is changing all the time, right? He's moving around. He's a busy guy. And so here he is at some instant when the final position that I'm interested in, and this is where he started up from. And so that's what delta x means. And that's a special term for this, and we use displacement. Okay, so displacement is like your change in position. So if I asked you, what's your displacement here? You would say, well, my displacement was plus 60 meters because I went from 0 to 60. My final position is 60. My initial position is 0. 60 minus 0 is 60. And so that's my displacement. Well, what's your displacement during this position, during this time, between 2 and 6 seconds? Well, I had no displacement. My final position, xf is equal to 60. My initial position is 60. 60 minus 60 is 0. My delta x is 0. Okay. Well, what about here? Oh, let's look at this one. My x final is 0. So my x final, I'll write it down here, is 0. Okay, my x final is 0. My x initial is at 60. So x initial is 60. So final minus initial is equal to 0 minus 60, or negative 60 meters. So my displacement is negative 60 meters. Before, it was positive 60 meters. So my displacement from here to here is positive 60. Displacement from there to there is 0. Displacement from there to there is negative 60. My net displacement is 0 because my final position and my initial position are the same. To find the net displacement, you don't really care which way he went. He could have gone this way, that way, that way, that way, that way, and there. If I ask you for what is the displacement for this whole trip, you just care about the final and the initial. If I ask you from here to there, well, that's your final, that's your initial. Okay? So in this case, if I look at this graph, my x final is 0, and my x initial is 0, and 0 minus 0 has been 0 for a while. Okay, so 0 displacement because, you came right back where you started. So your net displacement, we don't use the word total, we use the word net displacement because total is more like adding all the time, like, physical getting larger. But net can be a negative or a positive quantity. It's just what is the sum after you've put it all together. And so net all this from final to initial. Okay, that's on displacement and distance.